Evaluate by the summation the definite integral 1 to 2 x dx. In order to prove the problem, we'll use the formula that is integral a to b f of x into dx is equals to, we'll write it as a limit h tends to 0 h into f of a plus f of a plus h plus so on plus f of a plus n minus 1 into h. Now we'll take the problem, that is we'll write the given problem as I such that let I is equals to integral 1 to 2 x into dx. Now we are going to compare this integral. So we'll write it as comparing I with integral a to b f of x into dx. We get it as a is equals to 1 while b is equals to 2 and f of x is equals to x, and we'll calculate the h, that is equals to b minus a by n, that is 2 minus 1 by n is equals to 1 by n, where we'll get it as n belongs to capital N. Therefore I is equals to limit h tends to 0 h into f of a plus f of a plus h plus f of a plus 2h plus so on plus f of a plus n minus 1 into h. Then this can be written as a limit h tends to 0 h into, we'll write it as f of 1 plus f of 1 plus h plus f of 1 plus 2h plus so on plus f of 1 plus n minus 1 into h. So as a result, this can be written as a limit h tends to 0 h into 1 plus 1 plus h plus 1 plus 2h plus so on plus 1 plus n minus 1 into h. Then this can be written as limit h tends to 0 h into n plus, I'll take h common, we'll get it as 1 plus 2 plus 3 plus so on plus n minus 1. This can be written as limit h tends to 0 h into n plus h into, we'll write the sum to n terms formula n minus 1 into n minus 1 plus 1 by 2, so that minus 1 plus 1 will get cancelled, and we have to remember that nh is equals to b minus a, we will get it as how much? 1. Now we can write it as limit h tends to 0, we will write it as nh plus nh minus h into nh by 2, that is equals to limit h tends to 0 1 plus 1 minus h into 1 by 2. Then we'll write it as by substituting h as 0, we'll get 1 plus 1 by 2 is equals to 3 by 2.